Kubernetes has been getting a lot of attention, and there are good reasons behind that. At Grofers, we decided to migrate to Kubernetes almost 3 years back. Today, I want to talk about why we went in that direction and how it worked out for us. I work at Grofers. We are one of the largest online grocery service in India. We have been around for 8 years. We started as a hyper-local marketplace of grocery stores where customers can order online and get their orders within 90 minutes. There was a need for a convenient service like this in India, and we were solving this important need. We grew rapidly. As like most startups, we started with a crazy idea and faced multiple challenges along the way. We changed our core value proposition and the business model 4 times in the last 8 years, moving from a hyper-local marketplace to a centralized warehousing model for fulfillment to becoming a marketplace again that now delivers orders under 10 minutes. Each of these changes were pivotal in our journey. We would not have been able to survive and be where we are today without the tremendous agility built in our organization. We realized that our agility and speed is one of our core strengths for us to continue to be relevant and keep transforming ourselves. Today, we have about 2,000 employees directly working at Grofers. Technology function is about 250 people, including engineering, product, design, and data. Technology is truly at the heart of everything that we do. Pretty early, we realized that giving power to our developers to make their own technology decisions will be vital for our agility. We pushed the idea of developer and team autonomy as far as we could, adopted you build it, you run it philosophy, and enabled teams to take their own technical decisions, manage the entire stack, including infrastructure and operations like configuration management, scalability, resilience, and even handling production incidents. DevOps teams are essentially responsible for taking care of governance, for providing processes and tools for developers to really own the entire application lifecycle. Before Kubernetes, we were deploying to EC2 instances using Ansible and Jenkins. Common tooling was standardized, but not locked. So that also gave us the autonomy to go ahead and explore other tooling that may be better suited for certain use cases. So this setup led to a very diverse stack that grew organically rapidly. Public cloud, AWS in our case, made this autonomy possible to quite an extent. And then we moved to Kubernetes. Here's what we have been able to what we have done with Kubernetes at a high level in the last 2 years. 75% of our targeted production services are migrated to Kubernetes. By target, we mean that we don't intend to migrate everything like stateful services and some extremely slow-moving legacy services. There's a lot of benefit that comes when using Kubernetes for development and CI/CD. We practically develop in the cloud. Developers treat the stage Kubernetes cluster as an extension of their laptops. Complex integrated dev environments with more than 20 microservices can be created by anyone on demand under 10 minutes. And what it means for our developers is that we use a combination of tools built on open standards that work well for specific purposes, but at the same time, we limit them as well. While we have moved to Kubernetes, we still continue to use Ansible and our Ansible-based tooling for certain kinds of workloads where we feel it works best. In the larger scheme of things, platform teams continue to build abstractions that reduce ops overheads such as cost, security, and reliability so that developers can truly own things end to end. It took us a couple of years, engineering time from product and platform engineering, and hundreds of thousands of dollars to get to this. It was a big investment. So was it worth it? In early 2018, we realized that we had an illusion of agility. Teams were working independently on their microservices, deploying multiple times a day, but there were not enough guardrails for quality. We were creating waste and shipping poor quality products that were frustrating customers, internal users, and management. Our engineers were burning out as they were busy firefighting and shipping value to customers. We used to think that solving just infrastructure management and a delivery pipeline was enough. Saying you build it, you run it is enough, and our teams will write tests and own quality as they see appropriate. And to an extent, it happened. However, what we ended up was a proliferation of microservices that teams created to manage technology within their boundaries as they understood. And more often than not, the teams were not considering the impact of introducing new microservices on our overall architecture. We ended up with autonomous teams creating microservices independently to solve problems within their boundaries and under their control. Due to this missing guidance of an overall architecture, we ended up with microservices that were hard to develop, test, release, and monitor in production. In many cases, the boundaries were not clear enough, leading to slow releases. Our quality feedback loops were extremely poor, so poor that we were mostly getting to know about bugs from customers, customer support, and sometimes directly from the CEO. This is just unacceptable. Lack of technical oversight made this microservices architecture complex. While the infrastructure level processes were decently managed, application releases were manually tested, orchestrated, and testing for certain kinds of behaviors was just not possible. Whenever we would try to approach testing microservices, we would not be able to make any meaningful progress, as testing any one microservice was not enough. Our microservices lost their well-defined boundaries over time. We figured that we were now dealing with a distributed monolith that had become hard to reason about. The one lesson we learned in all of this is that if you allow your teams to launch more components autonomously and independently through self-serve tooling, they will do it. But if there's no framework to surface problems in your architecture and engineering practices, the complexity will become too hard to comprehend, and more mess will just pile on. Our developers were not happy because of poor developer experience. They were regularly dealing with bugs and incidents in production due to lack of testing. It was a stressful atmosphere at that point of time. In March 2018, we decided to slow down to find a viable way forward to ship fast enough without continuously compromising on quality and resolve the mess we had created ourselves. Since our microservices were not really independent, independently testing them was not enough. We decided to run automated regression tests on a distributed monolith to ensure that a change in any microservice should not break the product experience, which essentially meant running behavior tests on the entire backend for every little change. Our bet was that this would help us increase our deployment frequency again without compromising on quality. At the same time, it would give us a safety net to re-architect. We called this initiative Project Ship It, and we felt like